This video is going to cover the topic of satisfying inequalities. Be sure the date and topic are at the top of your page. The essential question for this video is, how do we name a solution that makes an inequality true, otherwise known as satisfying an inequality? Inequalities are similar to equations, which we've worked with, but instead of having something solved that's equal to a particular number, in an inequality there are often many possible solutions. The trick is that these solutions often have to be greater than or less than a particular value. We see inequalities written with symbols such as this, or sometimes greater than or less than with an equals sign attached. Right? An inequality might look like this, right? We read this as x is less than 5. And we can draw this on a number line to represent the inequality. The number line would look something like this, right? Where you have the open circle on the 5 and the arrow going to the left. There will be times when you are required to think of a number that makes an inequality true. You might need to find a value that satisfies the inequality. Looking back at our original inequality, right, x is less than 5, what is a value that would satisfy that inequality? Would 3 work? Would 7 work? Would 5 work? Right? These are some options. And I'm not sure, so if I look at my number line, right, I can kind of verify my answer. The direction of the arrow shows me what x might be. Since the arrow goes over 3, right here, the arrow goes over 3, I know it works. So this one would work. Right? 7 is in the opposite direction. That does not work. Right? And 5 doesn't work either because that circle right here is open. Right? So it doesn't include the actual value of 5. So 5 would not satisfy it as well. In these 3 choices, right, the only possible solution that satisfies, right, that's the word there, satisfies the inequality is 3. Of course, lots of other answers would work as well, right? So you could have said 1 satisfies the inequality, or 2.5 satisfies the inequality, or 0, or -11, right? All of these would satisfy the inequality because they are all numbers that are less than 5, which was what the original statement said. Let's brainstorm some possible solutions or numbers that satisfy the inequality of x is greater than or equal to 11. Let's try that one. I'll make a quick sketch on the number line just to have a visual, right? If it's greater than 11, that means it's going to the right. But it's also perhaps equal to, so I'm going to shade that in there. So this is how I would represent that there. So if I look at this, right, I'm thinking about numbers that would satisfy this inequality. Let me write down a few ideas here. So would 11 work? Would 3 work? 55 or 19, right? Do any of these satisfy the inequality? Well, looking at it, right, 11 certainly works because it's shaded in, right? That could count as a solution. 3 would be going to the left here, and that is not what we want, right? 3 is less than 11, so that will not work. 55 is more than 11, and so is 19, right? These all satisfy, and again, that's the key word here. And that's just a fancy word for saying that it makes it true, right? They're possible solutions that work in the inequality. What do we think about this inequality? Right? Notice that it's written differently, right? This time the x is written to the right, right? It's written to the right of the inequality symbol. So let's think about for a moment what that would look like and what would satisfy this inequality. First of all, when I read this, right, I see that this is 27 is less than x, right? But again, that's written in a different order than we're used to. So if I think about it, if 27 is less than x, then x has to be bigger than 27. When I hear it that way, right, it makes total sense. It's really clear. I only have to think about a number that is bigger than 27. So let me think. 50, right? 50 would work. 100 would work. Anything that's bigger than 27, right? 28 would work. These are all numbers that would satisfy it, right? So just be mindful that you might see these written in different ways, and you want to be able to think about what it truly means to think about numbers that satisfy the inequality, that make it true. Let's try one that's just a tiny bit more complicated, but still totally doable. So what if we have 4, which is less than x, which is less than 11, right? There's multiple things going on. We're actually pretty restricted here. We know that x, right, if I just look at it this way, x is greater than 4, right? That's what the first part tells us. But the second half tells us that x is also less than 11. If I put this on a number line, right, here's my 4. I know it's bigger than 4, so it's going to go this way. But if I get up to 11, I have to stop there because it's also not any bigger than 11, and it doesn't actually equal 11 either. So these are my only choices, right? So if I think about what would satisfy, well, 5 would work. Right? Check. 5 would work. 9 would work, right? That would be great. Anything that's in between 4 and 11 would work, right? 12 would certainly not work. 3 would certainly not work, right? So that one is a little bit more restricted. We're going to end with just a couple quick little practice problems. So you can go ahead and just make this quick table in your notebook, right? Shouldn't be too much. Just go ahead and write 4 columns. I'm going to give you the word version. We're going to write it as an equality, draw it on a quick number line, and think about what a possible solution might be that satisfies the inequality. So here's the first one, right? I would read this as x is less than 10. So I would write that as x is less than 10. And I'm going to make a quick number line here. Right? I'm just going to put 10 right there in the middle. And if it's less than 10, right, that means it doesn't include 10, so it's going to be open, going to the left, which means a possible solution would be anything that's less than 10. So maybe 4 or 0 or -2, right? Anything that is less than 10 would work there. Here's another one, right? I would read this as n is greater than or equal to 5. So I would think, okay, n is greater than or equal to 5. And on my very rough sketch here, right, I'll put 5 here in the middle. I'm going to think about what that means. It's greater than 5, so I know it's going to the right, but it also is perhaps equal to 5, so I'm going to shade that in there, which means a possible solution would be 5, right? That would work, or 12, or 81, right? Any of these numbers would work in this situation. You have one more example of this to do on your own for your turn, and it says x is no more than 8. So I'd like you to write the inequality, do a quick sketch of the number line, and record a couple possible solutions. Maybe I should put a little s here to say maybe give me a few options here. And remember, the essential question was how do we name a solution that makes an inequality true? And we know now that that basically just means what's a possible answer, right? What's something that would work for this inequality? So make sure you have this practice, make sure you have your notes, and bring any questions you might have to class.